Okay, good morning. So as usual on Mondays, let us start with solving these homework problems. So the first problem, let us read it here. So the problem is let a and b be real numbers and let for all values of x cubed plus ax times x plus 1 squared to be this polynomial x to the 5 plus 2x to the 4 plus x to the 3 plus 2x to the 2 plus ax plus b. If this is for all values of x, you're supposed to find a squared plus b squared and write it here. Okay, so the people, many of you that actually did the homework, did it correctly, so that's very good. But I want to make sure that you're really on the right track. Sometimes people can arrive to the correct answer with a little bit illogic. And let us make sure that this is not the case. Of course, if I want to do that, you already know that. I have a polynomial of fifth degree on the right, and I have another polynomial of fifth degree again on the left, because this is a third degree polynomial. This is the first degree raised to power 2 second degree. And if I have a third and a second degree multiplied, it becomes a fifth degree polynomial again. And you know that if this is supposed to be valid for all values of x, the rule is very simple: to organize them and compare them term by term. Compare the coefficients term by term, yes? So the first duty is to expand the left-hand side, because the right-hand side is already a standard fifth degree polynomial. It starts with the highest power of x, and it goes down for lower powers. So that's a standard, but this is not still standard. That's the whole point. So in order to make this a standard, it's just a very simple multiplication. Yes, before doing that, I have to raise this to power 2 because the priority is with power and then with multiplication. So I copy and paste the left side, the first pair of brackets, and then I square it, because this becomes the first square 2 times the first one times the second one plus the second one squared. Okay. Yeah, in principle, when you go line by line, you have to copy and paste everything, but I am a little bit lazy to do that. If you don't mind, let me just do it here now. So this one multiplied by that is x to the power of 5. This one multiplied by that is 2x to the power of 4. This multiplied by that is x to power 3 plus, multiply this by that, it becomes ax cubed. Multiply this by that, it becomes 2a x squared, and then finally I multiply this by that, it becomes ax. Yes? So I have 2 terms here, 3 terms here. In total, I should have 6 terms. 1, 2, 3, 4, 5, 6, that's good. But the problem is that even though this is a fifth degree polynomial, but it is still not a standard. Standard means that I should have x5 in one position and location, x to the power of 4 in one location, and etc. But you already see that I have x cubed term in 2 positions, and then it means that you need to factor that part out and write it as standard. Okay? So if I want to do that one, so this becomes x to the power of 5 plus, I have 2x to the power of 4 alone, but I have x cubed in 2 locations. So I put it out. From here, 1 is left. From here, plus a is left. And then I have 2ax squared plus ax. This is the left-hand side. The right-hand side, let us write it there. X to the power of 5, 2x to the power of 4, plus 2x to the power of 3, plus 2x to the power of 2, plus ax plus b. So I have a fifth degree polynomial on the left and a fifth degree polynomial on the right. This equality should be valid for all choices of x. It means that I want to make the left-hand side identical to the right-hand side. This can happen only if and only if term by term the coefficients are the same. So x5 has coefficient 1, x5 has coefficient 1, so there is nothing to do there. x4 has coefficient 2, x4 has coefficient 2 there, so that's nothing to do. But here, x cubic term has coefficient 1 plus 1, 1 plus a, cubic term has coefficient 2. So this means that 1 plus a should be what? 2. And it is extremely simple to find a. So a becomes just simply 1. Yes? And the point is that even though A is already found, you have to be careful about the other scenarios, because you might say that, okay, the coefficient of x squared is 2a, and I already know A, so what is the purpose of comparing them? Because I already know A. But don't do that. You have to do it. They can design a question in this way. For example, they can ask you, are there constants A and B for which this becomes equivalent to this or identical to this? For that case, you have to really care about other consistency scenarios. So that's why I'm saying that write all of them and make sure that all of them are working, even if you have found the unknowns before. So I would write 2a, which is the coefficient of x squared, and compare it with what? That one. So the good news is that this will also give me the same value. If it gives me the other value, for example, I don't know, might be, let us say this is 3. Let us say. And then I put 2a equals to 3, a becomes 1.5. Okay. This is very important to understand. Some students say that there are two values for a. One is a, one is 1.5. But that is wrong. The correct impression is that there is no a. Because I want to make all of them happening simultaneously. If one of them gives me 1, the other one gives me 1.5, 1 and 1.5 for the same variable a cannot happen simultaneously. So then it means that it is not possible to make this equivalent to this. It doesn't mean both of them are acceptable. But this problem was not that hard. Both of them give rise to the same value. So A1 so far is acceptable. But the problem is not finished. Here again, I don't have any problems at all, yes? Because X and AX are already the same, aren't they? Yes. So it means that A should be equal to A, which is always the case. And what happens for B? What happens for B? The constant term on the left is what? Constant term is a term without any x's at all. Do I have any term without any x's at all? Do I have? No. Yes? So here the constant term is 0, but what is the constant term there? B. So this means B should be 0. Yes? Am I right? Okay, but what we want a squared plus b squared. So it's 1 to the power of 2 plus 0 to the power of 2. 1 plus 0 is? Yes? So the correct answer to this will be 1. Any questions? Okay, so now let us go to the next problem. Let me read it for you first. Let p of x be a polynomial such that this happens. What is p of a square root of 5? There are probably different ways to look at this problem. So let us try to discuss at least 2 of them. Okay. So the problem is this. I know a polynomial. Usually we know how polynomials act on x. Yes, we usually write p of x is equal to something in terms of x. This is not in a very standard way. They are saying that p acting on x minus 1 is equal to this expression. Okay, and then you are supposed to find square root of 5. There are 2 different ways to look at this problem, but I want you to understand that. What is this telling you? I told you that already, that p is a function, and a function can be viewed as an operator. So here you send something in and you get something back. Usually we send x in, x is the input, and then we get something as the output. What is the input here? The name of the input, they have chosen not to make it express it as x, but x minus 1. So it means that your input is this, and when you are sending it out, it becomes 5. Then can you tell me what is x then? If the input is x minus 1, what is the name for x? Is x also the input? No, because the input is x minus 1. So what is x? X is your input plus 1. Is that right? Because if you say x minus y is my input, then I ask you what is x, then you will tell me that x is the input plus 1. Is that right? So in principle, x squared can be viewed as this. Of course, if you are confused, I will tell you a different way, but I want you to understand this is the scenario. Yes? Is that understandable for everyone? Yes? Instead of x, I have written x minus 1 plus 1. Why is that? Because the input is a little bit weird in this problem. The input is x minus 1. So x is not the input. Input is x minus 1. X is your input 1 unit more. So this is your input 1 unit more. Okay? I want you to understand when you say p of something except x is equal to this, understand that what is written here is your input. X is not necessarily the input. Is that clear? Okay. But now look, I want to calculate p of the square root of 5. If it was p of x equals to this, calculating p square root of 5 is extremely simple. If you don't understand, don't concentrate on this point. Forget about it. Okay? Let us go back. If it was p of x equals to this, that will be an E-level question. Because p of the square root of 5 will be what? Just take x out and put the square root of 5 in. But be careful. If I replace x with the square root of 5, what happens? If I replace x with the square root of 5, I have to replace it everywhere. Okay? Not subjectively. So I go here, I replace x with the square root of 5, and then this becomes 5 times square root of 5 to the power of 2 minus 10 times the square root of 5 plus 5. Okay, for the this becomes a number. For example, the square root of 5 to the power 2 is 5 times 525 plus 530. So this becomes 30 minus 10 square root of 5, which is a little bit weird number, but that's a number. But be careful, if you replace x with the square root of 5, you are not answering the question in the problem. You are answering what is p of the square root of 5 minus 1. Is that understandable? So when I replace, if you start here, replace x with the square root of 5, you have to do it faithfully. You have to replace x with the square root of 5 on the left. You have to replace x with the square root of 5, x with the square root of 5 on the right. But then it will give rise the correct conclusion. No one tells this is wrong, but this is not what is demanded in the problem, because I have calculated p of the square root of 5 minus 1. What is demanded is p of the square root of 5. Okay? This equality is true, but useless for the problem at hand. So now you understand that, okay, this is very simple. If I replace x with the square root of 5, because of this structure, I will calculate p of the square root of 5 minus 1. So it is not hard to see, okay, if I send a square root of 5, I am in trouble. I want to send something in so that it will calculate a square root of 5, p of the square root of 5. So instead of sending a square root of 5 in, what do you send in? Yes?
Square root of 5 plus 1.
Plus 1. Because you see, if I just naively send the square root of 5 in, I have to send square root of 5 here and there. If I do that, I get the correct answer for something else, which is not the one in the problem. I am calculating this. So I ask myself, what should I send for x so that the outcome becomes p of the square root of 5 as I want? Then you immediately realize that what you have to send in, as Abdullah mentioned, you send what in? Instead of replacing x with the square root of 5, I replace x with the square root of 5 plus 1. I replace x with this number, but after that there is a minus 1. Do you agree? And this is good enough, because this one that I anticipated for it, it will cause that these two are gone and p of the square root of 5 is 5. So then I go here, I will replace every x with, yes? I'm not saying this is the best way, but that is the one way. I want you to understand this idea. So, are you following me? So by that motivation I told you, this is the motivation why I am sending a square root of 5 plus 1 in anticipation of that these two will be gone. And then what is left for me is p square root of 5, and that is exactly what I need. Okay, on the right-hand side, I have a little bit of complication, but that is simple algebra. I have to be patient and do the algebra to make it simple. Okay, so let us do it together. If I want to make the algebra simple, hopefully you know that the pair of brackets prioritize this, and power has priority over multiplication. Don't multiply 5 in first. You have to be patient, write 5, and raise it to power 2. The first one squared is 5. 2 times the first one times the second one is 2 square root of 5, and the second one squared is 1. Yes? For this one, I cannot do anything except multiplying minus 10 in, so it becomes minus 10 square root of 5 minus 10, and then I have a 5 there. Let us simplify things a little bit and a little bit quicker. So 1 plus 5 is 6, but I have to multiply 5 in. So 6 times 5 is 30. 5 times 2 square root of 5 is what? 10 square root of 5. Agree? And then I have a minus 10 square root of 5 there. And minus 10 plus 5 is minus 5. Can I simplify even more? Yes, because I am lucky that these two ugly things are gone. And then I have 30 minus 5, which is 25. So the correct answer to this problem is 25. This is one way of looking at the problem. Yes?
Before you did that, when you found when you essentially replace x with x minus 1, can you expand that bracket before doing that?
Yeah, of course. I will tell you. So the reason I didn't brought this up, because I want to tell you that essentially this method, even though this becomes a little bit cumbersome, but if you are patient, it's doable. That's completely okay. I want to mention that this is simple, but it is not okay because you are answering a different question. But here we are answering the question that we want, but a little bit in a weird way, okay? Of course, if you realize that you can factor 5 out, it becomes much simpler, okay? So for example, this is another way to look at the same problem. Sometimes it is possible, sometimes it is not. So do you remember, this is the problem given from the very beginning. Yes? But because we also learned a little bit about factorization, this one is not hard. Can I factorize this? That's why sometimes factorization is helpful, even if the problem is not directly asking you about factorization. So here, I can factor 5 out, and I hope that you are good in detecting this pattern. Can you see that pattern? This is a squaring rule, yeah? So what can I write? I can write 5x minus 1 squared, and this is p of x minus 1. So if you are observant to understand this immediately, then the calculation will be the same. It will be simpler, but the logic will remain the same. So what was the logic? What should I send in to have p of the square root of 5? Again, the same logic. What should I send in? What should I send in? Square root of 5 plus 1. But there is a minus 1 here. But then you see what is the difference. The difference is that the algebra becomes extremely simple, yes? So it becomes 5, and instead of x again, I send what in? But I have a minus 1 here. Okay, are you following me or not? So I'm saying that this is one way of doing it, but if you are a little bit more observant, you can immediately see that, okay, even though the problem is not asking about factorization, but factorization here is very helpful, because when I do the factorization, I get something more compact, then I follow the same logic. It means that I want to have p of the square root of 5, so I will send this in, and then this becomes very simple. Do you agree? Because this 1 and 1 are gone, that is exactly the same logic, but what happens here, this 1 and 1 is also gone. And then I have square root of 5 to power 2, which is 5 times 5 is 25. So you see the calculation becomes simpler, but that's completely okay. Is that right? One other thing is that if I asked you what is p of x, yes? That is also another way. Some people say that, okay, from P of x minus 1, let me calculate P of x, which is the standard way, and then if I have P of x, I can simply answer P of any other number. Okay? That's also another logic. Okay, can you help me to find P of x now, if you understand it correctly? So here I have sent, so now let us go back to this diagram. This diagram tells you that if you send x minus 1, what do you get outside? You get this. So if you have the, if you understand what is going on, this algebra is very helpful actually here. So can you interpret that for me? I am sending x minus 1 as the input in. What does the function p do? It takes the input, because that is the same input, squares it, multiplies it by 5. Now, can you tell me what happens if I send x in? This p is the same machine, is the same operator. If you send x minus 1 in, you see what is happening. It takes the input you sent in and squares it, multiplies it by 5. Because this p is the same machine, it will do the same job for every input. So can you tell me what will be the output now?
5x.
5x squared, agree? So this, if someone asks you what is p of x, you answer it as 5x squared. Okay? So if you really want to find p of x, this is the answer. And using this, can I calculate p of the square root of 5? Yes, because this is the most standard way of writing functions. So what is p of the square root of 5? Because p of x is given, p of the square root of 5 means simply replace x with the square root of 5. So this becomes 5 square root of 5 to the power of 2, which becomes 25. So these are different ways of looking at the same problem. Yes? But did I answer your question, or was it different?
Yes, but also the minus 10x plus 5, what happened to that?
Minus what?
The 10x plus 5.
Minus?
On the top,
Okay.
minus 10x plus 5, what happened to that?
No, I factor 5 out. If I factor 5 out, this becomes x squared minus 2x plus 1. Because if I multiply back, it gives it's the same.
Yeah.
That is what 10x is. Okay? Is that understandable? Okay, so these are different ways of looking at this problem. Any questions? No? Yes?
What if one would just make the whole polynomial in an ABC form? Like you would write out a times x minus 1 to the power of 2, b times x minus 1, c, and then...
Okay, but we don't, okay, of course it might work, but we don't want to make the algebra cumbersome.
Right. Okay.
Yes? These are different ways of looking at the same problem, okay? Of course, I can give you another exercise. It is good to practice about it. Instead of giving you this, I can give you this. This is a better question. Might be we can make a homework out of it, but let us keep the same thing here and just change this 5 to 1. Okay? If I ask you about p of the square root of 5, I hope that you agree that at least you can do the same way as before. But instead of asking you about p of the square root of 5, if you are interested, calculate p of x. Here, the algebra was very simple to guess. So by changing this 5 to 1, the algebra becomes a little bit more complicated. I want you to see, can you find a way out of it? Okay? It is possible. It's not hard at all. Okay? But you can assume it as a different problem. Here I am not asking you to find p of the square root of 5. I am asking you to find p of x. This kind of reasoning might be helpful, but at the end the algebra is a little bit different, so you have to be a little bit more, smarter. Any questions? Okay, so we end this video here. Thank you.